This video is about graphing functions with a focus on linear functions. Linear functions are straight line functions, so when you graph them, they look like a straight line. This part of functions overlaps with some of the coordinate geometry of the line chapter. There are a couple of different ways in which we might be required to graph a linear function. We might see this type of question. We might be asked to graph the line, in this case it's f of x equals 3x minus 2, and we might be given a domain. In this case, the domain is -1 up as far as 3. If we see a question like this, we can approach it by drawing a table. Our headings for the table can be x, the actual function, in this case 3x minus 2, y, and our point. The point is simply what we get when we put the x and the y values together to make it into a point. Before I begin to work any of this out, just take a moment to have a look at the function 3x minus 2. And let's just have a think about why this might end up looking like a line when it's graphed. Well, we don't have any power on the x, and it's in the form mx plus c. This means that we're being told the slope and the y-intercept. And again, these are things that link into the coordinate geometry of the line chapter. On the left-hand side, I'm going to list out my x values. I've been told that my domain is -1 up as far as 3. That means I should go from -1 up as far as 3. So I've listed these values in the x column. Now I can substitute these into my function to get my result for y. Remember, this is exactly what happened in the functions chapter. We had an input. The domain is just the list of inputs. We put it into the function and we got an output. Remember, the point is just the couple that we can make. And this is the input together with the output. My next y value will be -2, meaning my next point is 0 minus 2. Pause the video here yourself and work out the remaining y values and points. When my table is finished, this is how it should look. I can also get this table by using my calculator. Now, I have the newer Casio calculator, so in my case, when I press menu, I'll press 3 for table, and it'll allow me to fill in a function. I'll type in my function 3x minus 2. X is over the bracket, minus 2. And when I have it typed in, I'll press the equals key to register. Some calculators will also ask you for a g of x, but I don't have a g of x in this case, so I just press equals to move past that. Then the table asks me where I want to start and finish. I want to start at -1, so I'll type in -1 and press equals. The end of my domain is 3, so I want to end at 3. And I'll press equals. And I want to go up in steps of 1, so I'll press equals. And here you can see that my table has the x values and the y values listed out. It doesn't give it to me as a point, but it's easy for me to put the x and y values together as a point myself. If I want to see more values in the table, I simply arrow down to see them. The information is the same as I have in the written table here on my page. I'd really encourage you to spend a little bit of time practicing using your own calculator to be able to type functions in. It's very useful, especially later on in quadratic functions. Now, because we're dealing with linear functions, it's important to note that when we go to graph, we don't actually need every single piece of information in this table. It's fine for me to use every piece of information if I'd like, but the first and last points will do me fine. So to graph this line, -1 minus 5 and 3, 7 will be enough. Now I want to draw my graph. The first thing that I must mark in are my x and y axes. Make sure, as always with a graph, that you space everything out by equal amounts on the x-axis and on the y-axis. Now I mark in the points, -1 minus 5 and 3, 7. And I finish the diagram by just joining these together. Notice that although I did not mark these other 3 points, the line passes through all of them. Notice also where the line goes through the y-axis. It passes through the y-axis at -2. This -2 occurs at the end of the function. And that value at the end is going to be the y-intercept. So that's the reason that we pass through -2 on the graph. Remember, to make your life easier in a question like this, make sure that you know how to type a function into your calculator. Also bear in mind that when you're finished putting functions into your calculator, when you turn it on, it's still going to ask you what function you want to type in. If you want to stop using functions and start using something else, then you need to reset your calculator, and you can do this by pressing Shift 9 and then 3 equals AC. Let's look at a second example like the first. In this case, the wording is very slightly different. It says graph y equals minus 2x plus 5 in the domain minus 2 up as far as 3. The difference here is that instead of having f of x, we have y. But it's the exact same approach. You'll remember from functions that f of x and y represent the same information. So now this time I'm going to work on the basis that we're using the calculator to do all our work for us. So when you input this information, the screen in your calculator should show you minus 29, minus 17, etc. The calculator screen, of course, will call this y f of x. That's fine, because as we said a moment ago, f of x and y are the same thing. Again, let's cut down the amount of work that we need to do. We're being asked to graph y equals minus 2x plus 5. Since this is a linear function, because it's written in the form y equals mx plus c, I only need to use 2 of these points. The best choice to make is the first point and the last point. Again, to draw my graph, I'll start by drawing the x and y axes. At a glance, I can see that I have to go much further up above the x-axis to 9 on the y-axis than I do go below. So it's only minus 1 down that I have to go, but I have to go up as far as 9. So that's why I've left more space above the x-axis and a little bit less below the x-axis. It's always a good thing to glance at the values like this before you begin to actually graph. So I've marked my values in, and now I'll mark my points in. And then I'll join them together to make the line. Again, if we look along the line, even though I've only marked the first and last points, the point minus 17 is on the line, the point 05 is on the line, the point 13 is on the line, and the point 21 is on the line. These are all the points from my table. These points are all what we call collinear, which just means that they're all on that line. Again, let's just take a moment to refer to a couple of the features of the line. Notice, for example, that the y-intercept occurs at 5, and we can tell this by looking at the function. It's indicated by the plus 5 at the end. Notice also that the line is sloping downwards. This is indicated by the fact that there's a negative in front of the value before the x. So a negative coefficient on the x means that the line will be sloping down. In this case, the slope of the line is minus 2, as indicated by the coefficient of x. There is also a different way that questions about graphing lines can be asked. You might be asked to use the intercept method. This just means that we need to find where the line passes through the x and y axes. The phrase intercept method may or may not be used in a question like this. The question might just state that you need to graph y equals 3x plus 6. Generally, if there's no domain given, then the intercept method is a good approach. To do a question in this way, I need to do 2 calculations. I need to figure out where the line goes through the x-axis, and I need to also find where it goes through the y-axis. To find where it goes through the x-axis, I'll take the function and put 0 in for y. To find where it goes through the y-axis, I'll take the function and put 0 in for x. Let's deal with the x-axis first. So looking at my function here, I want to let y be equal to 0, so I'll simply replace the y with 0. And now I'll solve this equation for x. So in this case, x comes out as negative 2. I want to write down the point that I'm going to graph. So this line will go through the x-axis at the point minus 2, 0. Now I look at the y-axis. So for the y-axis, I'll go to my equation, and where I see an x, I'll replace it with 0. Then I'll simply evaluate y. Again, I want to make note of my point. This time my point is 0, 6. Notice that in my point for the x-axis, I put a 0 in this position because I've used y equals 0. X always goes first and y always goes second. And in this point for the y-axis, I put in 0 for x because I was told to use x equals 0. So this is my x value and this is my y value. Now I want to graph my line. I'll draw my x and y axes, I'll draw in my scales, and then I'll mark in my 2 points. As usual, I'll join the points together to get my line. Notice, since the equation of my line was given in the form y equals mx plus c, I can make some connections between the information in the equation and the actual diagram. For example, the 6 is the y-intercept, and the 3 represents the slope. Notice this is a positive 3, and the line is sloping upwards. Let's look at one more example of how to graph a line. Notice this time my equation looks a little bit different. 2x plus 5y equals 10. Up until now I've had y is equal to or f of x is equal to. Dealing with a line in this format isn't a problem. I'll just use the intercept method. That means I'll find where it goes through the x-axis and the y-axis. Can you recall what piece of information I use for each of these? For the x-axis I use y equals 0, and for the y-axis I use x equals 0. At this point, pause the video and see can you figure out these 2 points yourself. Okay, let's take the x-axis first. For the x-axis, y equals to 0, so wherever I see a y in my function I replace it with a 0. And now I solve for x. So I have 2x equals 10, which becomes x equals 10 over 2, and so x equals 5. In this case my point is 5, 0. Remember, the x goes first and the y goes second. Now we'll deal with the y-axis. For this, x is equal to 0, so where the x occurs in the equation I replace it with 0. This gives me 5y equals to 10, which becomes y equals 10 over 5, and so y is equal to 2. My point in this case is 0, 2. Now let's draw our graph. I've marked in the x and y axes. Now I must put in the scales. I'll mark in my 2 points and I'll join them together to create my line. Notice that because the equation of the line was not arranged in the form y equals mx plus c, it wasn't as obvious from the equation what the y-intercept and the slope would be. Here's an extension question relating to area. This is a common type of question that gets asked about a line once it's been graphed. The question says, find the area of the triangle created by the line and the axes. So let's just start by identifying this triangle in the diagram. Can you see where it is? So this is the triangle in question. What type of triangle is it, do you think? It's a right-angled triangle. Remember the formula for the area of a triangle? It's a half the base times the perpendicular height, and it's available on page 9 of your log tables. So to find the area, I just need to decide what the base of the triangle and the height of the triangle are. In this case, the base is 5 and the height is 2. So the area can be calculated as a half, 5 times 2, which is 5 units squared.